Hi everyone, Mrs. Malchetter. We're going to talk today about pH and acids and bases. This is our very last topic in Unit 1. So pH and acids and bases. pH is a measure of the amount of H plus or hydrogen ions that are in a solution. And you can see here we have the pH scale. So some common substances that you might encounter, like lemon being at a pH of 2, stomach acid with lots of HCl in it as a pH of 1, some more basic things, bleach, don't drink it, and some other things like soap or Drano, drain cleaners. Okay. Our blood is around 7 point something, about 8, and water is neutral. Okay. So they have milk just slightly on the acidic side, but still, if you're trying to if you have acid reflux, they say having some milk or bread is an even better thing to do. So we're going to talk about pH today. So like I said, pH is a measure of how much H plus specifically ions are in a solution. But when we're measuring the amount of H plus, we're also taking into account the amount of OH minus or hydroxide ions that are in it. So when we think about it, is water is H2O, right? 2 H's and an O. Water can split apart, and we'll talk about this in a bit again, but when it splits apart, you get an H plus and you get an OH minus. Those are the two components that go together, okay? So we're measuring the amount of H pluses that there are. Now, an acid is considered anything that has a pH of 0 to 6. I can't think of anything that has a pH of 0, but on our scale that we were just looking at. So a pH of 0 to 6. And acids are things that increase the H plus ion concentration. What that means is they dissociate or break apart really easily, like in water. Like if you put HCl in water, that hydrogen and the chlorine, they're going to break apart, and it's going to leave a bunch of H plus ions sitting in the solution. So we call that an acid. So it increases the H plus ion concentration. Now, bases, those are substances with a pH between 8 and 14. And those are going to be ones that when you put them in a solution, they're going to grab those H pluses out of the solution. And so they're going to reduce the H plus concentration. So by doing that, they're going to be really good at taking those out. And then so that brings the pH up. Okay. And again, a base is anything from 8 to 14. Now we left off 7 because 7 is considered to be the neutral pH. That's where the amount of H plus and OH minuses are equal. And that would be like in pure water, pure distilled water that has nothing in it. Okay, so here's where I was talking a little bit about that dissociation and that breaking apart. So we've got down here, we've got a water. And if you add an H plus, a proton, okay, because that's pretty much all it is. When you take hydrogen and you strip its electron away, you're left with a proton. So you have a positive. So if you take a water and an H plus, they will combine to form a hydronium ion, an H3O. Okay, H3, the little white balls, and then O is the red one. And that's got a little bit of a positive charge because we've added that proton to it. Okay. Or we can take water and combine it with water, and this spontaneous dissociation happens. I don't remember exactly how many times out of so many million your book was talking about, but it does happen naturally where water will naturally dissociate into a hydroxide, which is an OH. There's an O and the H, which is a little bit negative. And then that other H that would have been here plops over to this one and becomes a hydronium or an H3O. Okay. So we get this one being a little bit negative and this one being a little bit positive. What does that mean for us and why are we looking at this? So we could measure or say substances are alkaline or acidic, or measure the alkalinity or acidity of a substance. And that's like basically taking the pH or measuring the pH. And remember, those acids have more H pluses, the bases have more OH minus. So there's this big trend right now, it might be starting to die down, but of drinking alkaline water. And that's water that has a pH somewhere between like 8 and 9. Okay, I've seen some waters as high as 10, but somewhere between like 8 and 9. And it's supposed to have benefits for your body in removing free radicals or things that are particles that are hanging out on and altering your DNA. It's going to help balance your cells out. If you have a lot of acid reflux, it can help with that because it's going to help buffer the or change or subdue the acids. So getting to buffers. Buffers are any substance that can minimize those changes in the H plus and OH minus concentrations. So they're going to help to balance us back out. We as humans cannot survive for more than a few minutes if our total blood pH is off the normal of 7.4. So somewhere, I mean, everybody is slightly different, right? But somewhere in here is our normal pH. You can get acidosis if you go too far below, and you can see if you get below 7, that's kind of dead. Alkosis is having too high of a pH, and if it goes way too high, you can die. Now, I'm not telling you you're going to drink 1 bottle of water and die. No, because this has to be your total blood pH, and your body keeps itself in homeostasis. And part of drinking that water, if you do decide to drink that alkaline water, is it helps to eliminate some of the acids that are in your system. It buffers them out. It takes those H pluses and it holds on to them, okay? Because a base or a more alkaline substance is going to have some OH minuses, which can bond really nicely with those H pluses to make H2O. Okay, so that's why it's important to us. We have to maintain our blood pH. We have to maintain a neutral state, a homeostasis for ourselves. And you will be working on a few review questions that will go over the different pieces of pH and buffers and why buffers are important. And we do have a lab coming up on them. Enjoy your day. Thank you.